Hello, good morning, everyone. So today's topic we are going to discuss is about NAT and PAT. So NAT stands for Network Address Translation. And PAT stands for Port Address Translation. So now why we require NAT and PAT? Yes, guys, why we require NAT and PAT? Any idea?
For security purpose to hide our IP, or for internet we don't have much more public IPs.
Much more. Okay, it's a process of converting your public IP into private and vice versa. So this is why we use this NAT and PAT process. So please make a note. So why we need to convert is, so your public IPs are routable in the internet, whereas your private IPs are not routable in the internet. So we use a mechanism called NAT or PAT in order to convert these public IPs into private IPs and vice versa. So we'll talk about the scenario, how this works, and then we'll see how to implement static NAT, dynamic PAT, and dynamic NAT. This is clear? Okay, now, so let us consider we have host 1. We have R1. So R1 is connected to the ISP. So let us consider this as R2. And we have a server. Let us consider the IP as 8.8.8.8. So let us consider the host 1's IP as 192.168.1.1. So R1's IP as 4.4.4.2 and R2's IP as 4.4.4.1. Now, so whenever host 1 wants to have the reachability or access the Facebook server, let us consider this as a Facebook server. Now, so what will be the source IP? Source IP will be 192.168.1.1. What will be the destination IP? Destination IP will be 8.8.8.8. So now, so when the packet hits the R1, so what R1 will do? R1 will do the destination lookup. So it will see whether it has a route for 8.8.8.8.8. So it will forward the packet towards the ISP, and then it will reach to the, what is the Facebook server. So let us consider we are pinging this IP. Let us consider we ping on host 1 8.8.8.8. So now we don't have a problem with ICMP echo request. So reachability is there and everything is fine since we have a public IP. Now, so when the server replies, with ICMP echo reply. This time, what will be the source IP? So source IP will be 8.8.8.8 and destination IP will be 192.168.1.1. Now, as soon as this packet is sent to the router 2. So what router 2 will do? Router 2 will do the destination lookup. So now the problem is R2 will drop this packet. Why? Because inside the ISP, let's consider this as the ISP router. ISP router. This is ISP router. So what ISP will do? ISP will not route this private IP. So your packet will be dropped here. I hope this part is clear. So your private IPs are not routable in the internet. So in order to route these private IPs, what we do is we implement the concept of NAT, network address translation. So in NAT, we have two types of NAT, that is static NAT and we have dynamic NAT. So what do you mean by static NAT? We call static NAT as one-to-one mapping. Means for one private IP addresses, we require one public IP address. So let's consider we have 10 private IPs or 10 hosts that want to reach to 8.8.8.8. Then we require 10 public IPs. This is one-to-one mapping. But the problem is public IPs are not free of cost. You need to pay some cost to buy these public IPs. So now, if you talk about the dynamic NAT, so now you need to buy a pool of IPs here. So we'll be configuring a pool here. So automatically when the host hits the R1 router, let us consider this as the NAT router, which is doing the translations. So on R1, we'll be creating a pool of public IPs. Again, you need to buy this pool of public IPs so that R1 will send the traffic from different hosts to your Facebook server. So again, the disadvantage is buying these public IPs. So one more method we have, that is PAT. So first we'll see how to implement static NAT and dynamic NAT, and then we'll see the PAT concept. Now, how this static NAT concept works. Now let us consider we have the same scenario, static NAT. So we have host 1. We have 192.168.1.1. We have R1. We have the ISP. Then we have the server. 8.8.8.8. Now, let us consider this IP is 4.4.4.4.2 and this is 4.4.4.1. Now, so this will be our NAT device who will convert your private into public and public into private IPs. So let's consider the source IP will be 192.168.1.1. What will be the destination IP? Destination IP is 8.8.8.8. So this time what we'll do on R1 is we'll create a static NAT, means one-to-one mapping. So what we'll be doing is we'll be converting this private IP into this public IP. So you can use the exit interface IP in order to convert this private into public. This time whenever R1 is requesting, what he will do, he will change the source IP. Source IP will be 4.4.4.2 and what will be the destination IP based on the policy or based on the not on the policy, based on the NAT configured on R1. So it will change the source IP to 4.4.4.4.2 and destination IP will be 8.8.8.8. So now this will be routed towards the ISP and it will reach the server. Now, whenever server replies, what will be the source IP? Source IP will be 8.8.8.8. And what will be the destination IP this time? So it will be 4.4.4.2, but 4.4.4.2 is a public IP. So now as the server replies to ISP router will do the destination lookup and forward the packet towards the R1. Now what R1 will do again? So R1 will again convert this destination IP into your private IP. So source IP will be 8.8.8.8 and the destination IP will be again converted to 192.168.1.1 when R1 is sending the packet. So due to the translations configured on R1, it will change your public into private IP and it will route the packet towards the host one. So this is how your static net works. So we'll see the configurations now, how to configure this static net. So let us consider we have one router. So we'll be using router as a PC and router as a server as well. So let us consider we have three routers. So the IP address between your PC1 and R2 will be 192.168.12.0/24. So the IP address between R2 and this server will be 192.168.23.0/24. So it will be .1. This will be .2. This will be .2 again, and this will be dot. So now, so we'll be disabling your IP routing capability on PC1 and this server. So using the command no IP routing.
One thing more, Chetan, like you said that private IPs are not routable, right?
So we are just for example sake I'm using. Okay.
No. I'm not relating with this, right?
Okay. Ah.
If we have a BGP peer, right, with our CE to ISP router, if we advertise our private route pool, then what will happen?
No, tell me, come back again. I didn't hear you properly.
If we have a BGP pairing with our ISP, right?
BGP pairing, okay.
Then if we advertise our private pool into that BGP, then what will happen?
You'll configure NAT there, right? So it will convert your private into public, or you can use PAT as well.
No, that is a different concept.
Mhm.
Use public private IPs are not routable, right? But if
Correct.
we advertise that pool into our ISP network with the help of BGP, then what will
That
happen?
is something very different conflict. That is MP BGP you're talking about, right? Multi-protocol BGP.
MP BGP, like it's not
I'm
MP
talking about,
BGP.
see, I'm talking here about the concept, how this NAT and PAT works. That you are that what concept you are taking is, if you have the same autonomous system number, private AS and public AS, that
No,
comes
no,
into a
no,
different term.
no. I'm not talking about that. I'm talking about in general. What will happen if we'll advertise our. You are talking about MPLS where C BGP. No, leave it that part.
Then
We have just a internet connection, okay, where
okay.
ISP give us
Uh-huh.
the
Private
that,
IP. Mhm.
yeah. Then
Mhm.
what will happen if we advertise?
It will convert the private into public, right? Then only it will route the internet. Otherwise, how your public IPs are routable on the internet?
No, netting is not comes on the netting. Like you again mixing the netting and with the what we, if we are not able to advertise it, but if we advertise, what will happen?
What will happen, man? That only I'm saying it will convert the private into public IP. It will, first of all, it is not routable on the internet, right? First of all, do you think what do you mean by private IP? First of all,
Sorry,
what do you mean by private IP?
which is
We use inside the land, right?
yes.
Which can't be routed on the ISP. So ISP's work is to convert, right? We are just seeing the procedure how it converts. But ISP will convert your private into public. Otherwise,
We have so much public IPs on our CE, right? On
where you have
CE,
public IPs? How many public IPs you have?
like we have a pool, whatever ISP give us. It's not about only two IP, three IP. Sometimes ISP give us pool
That
according to cost,
correct. So you have paid the
right?
cost, everything is fine. So,
Yes.
that's what I'm saying. We can configure dynamic net. So we can convert private IP into one public IP using the pool of IP addresses.
Again, you are mixing the NAT and the
NAT,
leave
NAT,
it.
static NAT and dynamic NAT I'm talking
No,
about.
I know that concept, but
Then,
I'm just asking,
uh-huh.
what will happen if we advertise our pool towards ISP? What will happen? Along with the pools which we buy from them, along with another pool which we added, then what will happen?
I'm not getting you, man. What pool? I didn't get you.
Okay, leave
Okay,
it. Leave it.
okay. Ask me after the class. Okay, let me finish this. So on the PC one. So on PC one. Disable IP routing. So no IP routing. So interface 0 bar 0. So IP address will be 192.168.12.1/24. No shit. So IP default gateway 192.168.12. So this is the configuration on PC1. Show IP route. This is your default gateway, and show IP interface brief. This is your IP address. Now, so on R2, Host name will be R1. Sorry, R2. So interface is 0 bar 0. So IP address will be 192.168.12.2/20. No shit. So interface Z0 bar 1. So IP address will be 192.168.23.2/24. So on the server, host name will be so no IP routing. So interface Z0 bar 0. So IP address will be 192.168.23.3/24. No shut. And IP default gate 192.168.23.2. Now go to PC1, ping 9168.23.3. So it is reaching. So let me go to the server and enable the debug IP packet. So now, so when you ping from PC1 to the server, that is 23.3. So now if you check the source IP and the destination IP, source IP will be what you say 12.1 and destination IP will be 23.3. So this is before implementing NAT here. Now, so now how to implement NAT? So in order to implement NAT, the step 1 will be, so you need to specify the inside and the outside part. So inside will be your LAN and outside will be your WAN. So then you need to create the NAT translation policy on R2. So these are the two steps you need to create on the router 2. Now, so this will be your so inside part. This will be your outside part. So now we need to go to R2. So interface G0 bar 0. So IP NAT inside. So interface G0 bar 1. So IP NAT outside. So now you need to convert your private into public using the command IP NAT inside source. So source static. So I'll be implementing the static NAT. Then I need to convert my 192.168.12.1 to your public IP. That we can use the interface IP as well. So let us consider we are using 23.2 only, or you can use public IP as well. So whatever you bought from the ISP. So let us use 192.168.23.2. Enter. Now, So private IP will be 192.168.12.1. So public IP will be using is your interface IP. That is 192.168.23.2. Now, so now when you initiate a ping from PC1, so if you check the NAT translation, show IP NAT translations. So can you see now your 12.1. So 192.168.12.1 will be converted to 192.168.23.2. Can you see here? What is the inside local? And this is the inside global. What it is, it will be converting. Then again, when the when the server is replying back, then it will check this 192.168.23.2 and then it will convert back to your private IP. So now go to server and check the translation. Now can you see what is the source? From which source I'm getting the IP? Now I'm getting from the source 23.3. Sorry, not here. This is 23.2. What will be the destination? Destination will be 23.3. Now your private IP has been converted to public IP by the NAT. I hope this concept is clear. This is about static NAT. Now if we talk about dynamic NAT. So with dynamic NAT, we can configure a pool of IP addresses. So we'll include one more host here. So let me say this router. So let me include one more host. PC2. We'll take a switch. Just wait. Now, if we implement static NAT, now we require what do you say? Two public IPs. So instead of that, what we can implement is dynamic NAT. We can buy a public pool. So automatically, what this pool will do is whenever the host one or the PC1 requests for R2, R2 will release the public IP from this dynamic pool what we create on R2. The same way, when PC2 requests for a public IP, so then R2 will convert that public IP with the help of this dynamic pool what we have created on R2. Now, so let me go to PC1. So now IP routing. So interface 0/0. So IP address will be 192.168.12.1/20. So IP default gateway. We have 192.168.12.2. So on PC2, nine to 168.12.3/20. No shit. So IP default gateway 9 to 168.12.2. So on R2. So interface 0/0. So IP NAT inside. So IP address will be interface is 0/1. IP NAT outside. So show IP interface brief. Let me up interface range 0/0 to 1 and motion. So now, so on the R2, you need to create a pool first. So you need to convert your multiple private IPs into multiple public IPs. So we create a pool on R1. So the configuration will be IP NAT pool. So you can provide a name of the pool. Let us consider we are giving the name as Cisco. Now you can define the range of public IPs. Let us consider I want to use 192.168.23.10 to 192.168.23.20. And need to specify the subnet mask, that is /24. Prefix length, that is /24. Now, so you need to create an access list here in order to permit the traffic. That is what you want to permit. You want to permit your 12.0 network. So create an access list, one permit. So what you want to permit? You want to permit the 192.168.12.0 and the wildcard mask. Enter. Now create IP NAT inside source. So now we'll attach your list one, that is your private IPs, to the pool of public IPs, that is pool and the pool name, that is Cisco. Now, so now when you initiate a ping from host one or PC1 to 192.168.23. You would reach. So now check the translations. Go to R2, show IP NAT translation. So this time, so whenever one minute. So go to one minute PC2. So let me ping to 192.168.23. Go to R2. Now, can you see? So now it is converting your 192.168.12.3 with the another IP address. So let us consider we had one more host 192.168.12.4 that will be converted to another public IP that will be released from your pool. That is 192.168.23.10 to 192.168.23.20. So inside this, so first PC will get 10, second PC will get .11. So like that, it moves on. So until unless we have what is the public IPs in the pool, that many hosts will be reachable. Let us consider we have 10 public IPs, then you can allow 10 private IPs to communicate with the server. So the problem here with NAT is you need to buy a pool of public IPs. So the problem with NAT was one-to-one mapping. So for every private IP, you need to have a single public IP addresses. So that's why we don't use the concept of NAT now. So that has been now converted to the PAT. So port address translation. So now what this port address translation does? So with one public IP, we can map 65,534 private IPs. So now it will differentiate the traffic based on the port numbers. I hope this part is clear. Any doubts still here? No doubts? Okay, now we'll see how to implement PAT. So let me enable the telnet service and HTTP service on the server. So line BTY 0 to 4. So login local, transport, input, telnet. So create a username, Cisco, password as Cisco. So now, so enable the HTTP service as well. Do show run pipe section HTTP. So by using the command IP HTTP server. So now, so let me go to R2 and create that. Okay. So we have inside and outside. Now, so now in order to implement the PAT, so you need to create an access list. Access list is one. So what you want to permit? You want to permit the private IPs, that is 192.168.12.0/25. That is wildcard mask. So now, so the command will be 192. Sorry, not the command. So the command will be IPNAT inside source static. And now you need to match the what you say list one. Sorry, 1 minute. Okay, IPNAT inside source list one. Then you can use interface IP, that is G0 bar 1 and overload. So this what overload will do is it will convert your private IPs into public IPs with the help of PAT configuration. That is port address translation. So using the ports, now your private IPs will be converted to your public IPs. Let me go to host one. So let me telnet. Telnet 192.168.23.3. Enter. Cisco. So now if you talk about the NAT table on R2, so show IP NAT translation. Now, can you see the port number what it is using? So in order to convert this 12.3, that is 14051, this is the random port number, and this is the telnet, that is 23. Now it is converting the private IP of 192.168.12.3 into 192.168.23.2 with the help of 14051 port number. Now, so let me go to PC2 and again implement what is it? This time HTTP here. So that is 80, enter. It's open now. So go to the translation table. So now if you check, can you see? Now. So again, the private IP is the same, and based on the port numbers, it will differentiate the traffic. Can you see here? So with the help of only one, what is a public IP, that is 23.2, it is converting your private IPs. Now it is differentiate the traffic based on these port numbers. So with the help of one public IP, we can convert up to 65,535 public IPs. So this is about the PAT concept. So now we'll talk about BGP. So attributes. So I'll quickly show you 3 attributes. So we have wait. So this will be seen in your CCI enterprise. So let me quickly configure because I have patch to finish. So local preference, we'll see, and then we'll see MED. So we'll finish off wait, local preference, and MED. So AS path prepending, you can learn in CCI enterprise because this will be again taught in the lab. So I'll just show you how to implement wait and local preference. So if possible, MED, because I have one more batch to finish after this, or we can have one more class as well. That is not at all a problem. So let me implement wait. So always highest wait is preferred. So if we talk about the wait, so if we talk about the wait, first of all, wait is a Cisco proprietary. Second, if we talk about wait, it is local to the router. And third point about wait is always highest wait is preferred. So now we'll see how to implement wait. So let us configure. Let us consider we have R1, we have R2, and we have R3. So let us consider R1 is in AS1, and R2 and R3 is in AS23. So this is 192.168.12.0/24. 192.168.23.0/24. Sorry, not 23, 13.0. Let us consider between R2 and R3 to 192.168.23.0/24. Now, so let us consider we have a loopback. So 23.23.23.23/32. We have one more loopback, 23.23.23.23.23. Same loopback. We can configure an R2 and R3. Then we'll see how your R1 will select for this loopback. And then we'll see how to implement the wait attribute in order to select the path. Okay. So let me configure this first, and then we'll see how to configure wait active. So let me take 3 routers. So R1 is in ASN1. And this is in ASN 23. /32 on R2 and R3. So R1 is in autonomous system number 1. Sorry. So the IP address between R1 and R2 will be 192.168.12.0/24. So the IP address between R1 and R3 will be 192.168.13.0/24. And the IP address between R2 and R3 will be 192.168.23.0. So I'll show you how wait and local preference works. So please go with the MED. So any doubts, please ask me. So we have R1, we have R2, and we have R3. I'll show you how to configure wait and local preference. So you can just check with the MED. So any doubts, please come back to me. I'll just tell you how to configure MED as well. So this will be taught in CC Enterprise, don't worry. So these attributes will be again taught deeply. So they'll tell you how to implement wait, local preference, MED, AS path prepending as well. Just wait for the console. So on R1. So let me create a notepad. So interface, this is reversal. So IP address will be 192.168.12.1/24. No shit. So interface 0 bar 1. So IP address will be 192.168.13.1/24. No shit. So router BGP. So router BGP 1. So BGP router ID will be 1.1.1.1. So neighbor 192.168.12.2 and the remote is will be 23. and neighbor 192.168.23 dot, sorry, 13.3. What is the remote ace? Remote ace will be 23. So on R2, so interface Z0 bar 0 will be 192.168.12.2 and Z0 bar 1 will be 192.168.23.2. We have a loop back. So interface loop back 0. So IP address will be 23.23.23.23/32. So router BGP 23. So BGP router ID will be 2.2.2.2. We have neighbor 192.168.12.1. So remote ace will be 1. We have one more neighbor, that is 23.3, and remote ace will be 23. So advertise the loopback, that is 192.168. Sorry. So network will be 23.23.23.23. Specify the mask, that is /32. So now we'll configure on R3. So on R3, Z0 bar 0 will be 192.168.13.3 and Z0 bar 1 will be 192.168.23.3. So then we have a loop back, that is 23.23.23.23. So router BGP 23. So router ID will be 3.3.3.3. So we have neighbor with 192.168.13.1. Remote ace will be 1. And then we have neighbor with 192.168.23.2. Remote ace will be 23. Then we need to advertise this loop back. So now we'll copy paste. So on R1. So on R2 and on R3. Now go to R1. So if you check show IP BGP summary. You have two adjacencies, show IP BGP. Just wait. First check on R2 whether it has advertised locally. Wait 1 minute. Yes. Now go to R1. Show IP BGP. So now if you talk about BGP, so now it is choosing what is the next hop as? It is choosing the next hop as 192.168.12.2. So with weight, what we can do is we can just set a higher weight on R1 towards the next hop of 192.168.13.3 and you can influence the route. So whenever R1 wants to reach the network 23.23.23.23, so it will choose the next hop as 13.3. How? Based on the weight attribute. So can you see by default the weight is 0, 0. So how to set that? So you need to go to router BGP. So it's very simple. Go to router BGP 1. So neighbor 192.168.13.3. So now I want to set the higher weight on the next hop 192.168.13.3 with the command wait and the question mark. So you can set any weight between 0 to 65535. Let us consider I want to set it as 500. Now, and this weight is Cisco proprietary and is local to the router. Now, if you check show IP BGP, just wait, clear IP BGP star sort. Show IP BGP. Now, can you see? So now it is using the next hop as 13.3. Why? Based on the weight attribute that is set to 500. This is how you use weight to influence the traffic. But the problem with weight is it is local to the router. Only in the case of scenarios where R1 want to influence what is say the routes, then you can use this weight attribute. I hope this weight attribute is clear. So quickly, I will show you local preference as well. How local preference works. So the advanced part you will see in CCI Enterprise. So you can even use the policies and you can just configure the route map as well and set the weight attributes, and then you can set the weight using the next hop. That and all you will see in CCI Enterprise. So next, if you talk about local preference. So first of all, local preference is used, sorry, not used. So always highest is preferred. So it is carried inside IBGP, but not to the EBGP neighbors. Yes. So you can influence the path using a local preference and it is carried inside your IBGP. So now how to do that? So let us consider we have a scenario. So we have R1. So we have R2. We have R4. And we have R3 here. Let us consider R1 is in autonomous system number 1. And R2, R3, R4 is in ASN 234. So let us consider we have a loopback 1.1.1.1 slash 32. Now, so if we talk about from the R4's perspective, let us consider we have configured BGP here. So we have used, this is the eBGP, and this we have configured with IBGP. So now, so if we talk about R4's perspective of selecting the path for 1.1.1.1. So whenever you check show IP BGP, so let us consider. So 1.1.1.1, it is taking the next hop as 192.168.13.3. So now, so this is the star and the valid path, and we have one more route that is 192.168. Not 13.3. Sorry. So let's consider this as 34.3 and this as 24.2. So let us consider now it is choosing the next hop as 34.3 towards R3. So with the help of local preference, what we can do is we can just tell our R4 to choose the R2 as the next hop in order to reach to 1.1.1.1. Okay, we'll see this how it works, and then I will end this. So if you have any doubts, please ask me. Please WhatsApp me. So whenever I'm free, I'll just reply back. So let me create a lab. So local preference. So let us consider we have 4 routers. So we'll take one more class, Manoj, because I have one more batch now to continue. I'll just take one more. That will take some 15-20 minutes. I'll just discuss that. So we'll take 4 routers. So R1, we have R2, so we have R3 and R4. So this is an ASN. So now this is ASN 234. So the IP address between R1 and R2 will be 192.168.12.0/24. And 13.0, which is 24. So we have 34. So let's consider we have a loop back on R1. That's 1.1.1.1/32. So let's just configure on the notepad. So on R1, G0 bar 0 will be 192.168.12.1 and G0 bar 1 will be 13.1. So router BGP1, BGP router ID will be 1.1.1.1 and neighbor 12.2, remote AS will be 234. And 13.3, remote AS is again 234. So then we have a loopback. So interface loopbacks. So IP address will be 1.1.1.1/32. So network 1.1.1.1 mask/32. So on R2, so G0 bar 0 will be 12.2 and G0 bar 1 will be 24.2. So interface, we don't have a loopback here. Quickly remove this. So router BGP 234. So router ID will be 2.2.2.2. So neighbor 192.168.12.1, remote AS will be 1, and we have one more neighbor, that is 24.4, and remote AS will be 234. Don't have a loopback. So on R3, so G0 bar 0 will be 192.168.13.3 and G0 bar 1 will be 34.3. So router BGP 234. So BGP router ID will be 3.3.3.3. So neighbor 13.1. So remote AS will be 1. We have 34.4 and remote AS will be 234. This is an R3. So now final configuration of R4. So G0 bar 0, IP address will be 192.168.24.4 and G0 bar 1 will be 34.4. So router BGP 234. So BGP router ID will be 4.4.4.4. So neighbor 192.168.24.2. So remote AS will be 234 and 192.168.34.3 remote AS will be 234. Just copy paste R1. So go to R1. And R4. So just wait. Show IP BGP summary. Two neighborships on R1. Show IP BGP summary. R2 neighborships. We'll go to R4. Show IP BGP summary. This fine. Show IP BGP. Just wait. So let's go and check on R1. Show IP BGP. Just wait. So go to R2 and R3. Show IP BGP. Let's go to R4. So now, just wait. Why it is changing? Why is not changing the next stop? Yes. Can you see the next stop here? What it is? 13.1 and 12.1. So what should be the next stop? It should be 24.2 and it should be 34.3. So because of next stop self. So whenever any eBGP neighbor advertised to any iBGP neighbor, iBGP will not change the next stop. So you need to go to R2 and on R3, you need to configure next stop self. So go to R2 and R3 and implement next stop self, and then we'll see how to implement local preference. Sorry. So not on R1. Go to R2 and R3. So router BGP 234. So neighbor 192.168.24.4 next stop set. Just go to R3 as well and implement neighbor 192.168.34.4 and next stop set. So now go to R4. So just wait. So clear IP BGP star soft. Show IP BGP. Can you see now? So due to next stop steps. So that's why whenever eBGP enable advertise to iBGP, iBGP will not change the next stop. Now, so R4 is preferring 24.2. What do you say as the next stop? So with local preference, we can just alter this next stop. So we can make R4 to use R3 as the next stop. Now how to do that? So you need to go under R3. So go to R3 and configure local preference. So how to do that? So router BGP 234 BGP local preference and question mark. So you can select the local preference between any of these values. Let us consider I configured 1000. So now if you go and check on R4, now it will choose the next stop as what you say. Just wait, clear it, clear IP BGP star soft. So local preference by default is 100. So now show IP BGP. Can you see what it is choosing? The next hop as 34.3. Why? Based on the local preference. So like this, you can influence the routes with the help of BGP attributes. So your MED part and AS path preprinting will be taught in CCI Enterprise. So go through that. So I'll give you the what to say lab access as well, means workbook for BGP. So just go through that. And SI query and SI reply, I have a video. I'll just share with you. Or if you guys have any doubts, please come back to me. I'll just explain this. I require just 15-20 minutes to explain this. So we can have another session of 20 to 25 minutes. Please let me know when we can have this session for SI query and SI reply. So by today evening, if it is possible, we can have a session, just a 20-minute session for this SI query and SI reply. This is about the theory part. And other than this, that's all guys. So it was a little bit of a hurry. So sorry for that. So